Greetings, myself Sandeep, and we are from Group 28, Batch 28, and we are dealing with a project called Cloud Native Scalable Web Application. It's completely based on DevOps project, and this project eco-friendly is a cloud native scalable web application designed to guide environmental volunteers. The platform allows user to register, view available environment activities, and the application is deployed on the cloud environment to ensure the availability and scalability. It follows the DevOps practicals, automation, deployment, and continuous integration, which is called CI/CD. And coming to the introduction part, the platform simplifies environmental volunteering by providing a user-friendly interface. Volunteers can easily access and register for activities. The system supports multiple users and dynamic data updates. Cloud deployment ensures accessibility from everywhere. Eco Engage improves coordination and participation in the system uses a full stack architecture with the front end, back end, and databases. MongoDB used as the storing volunteer and task information application is deployed using AWS Linux instance. And the context is the rapid growth of CA cloud computing and DevOps has transformed modern web application. And the popular statement is environmental issues like pollution and deforestation requires a community participation, but many willing volunteers access organizer platforms. So we came with an approach called a full stack development with infrastructure and automated DevOps pipelines. And the main objective of the our project is to develop a cloud native web application for environment volunteering. The system aims to provide a centralized platform where volunteers can find and participate in environmental tasks. It also aims to improve the coordination between the volunteers and organizations, the participation, the application focus on usability and accessibility. Another objective of implementing DevOps participates for automated deployment CI/CD pipeline is configured using GitHub, which ensures the contiguous CI/CD and automation reduces manual deployment. The system becomes reliable and maintainable. The project aim is to use cloud infrastructure and scalability. AWS EC2 Linux instance is used to host the application, and the cloud deployment ensures the high availability. The system can handle increases the number of users, improves the performance and reliability. Overall, the main objective is to build a cloud-based environment and voluntary platform that automates, enhances deployment, and cloud in architecture supports scalability. And coming to the existing system, in the existing system, environment volunteering activities are organized manually, and volunteers rely on social media posts, emails, and local announcements. These methods are not centralized. Information is scattered across different platforms. Volunteers may miss opportunities. So, manual coordination lacks and leads to the communication delays. Organizers need to contact volunteers individually. Tracking the participation becomes difficult, and the existing platforms are also lack scalability as the number of volunteers increase and the management becomes critical and the performance issues occurs. The effects coordination. So there is a lack of a centralized data storage. Volunteers informed is not stored securely. Tracking previous activities becomes difficult. This reduces the system reliability, data and inconsistency occurs. The existing system does not automation and no CI/CD pipeline is used. This slows the development process. System architecture becomes difficult here. So that's coming to the proposed part. And the statistical websites or existing platforms provide information but lack inaccurate features like registration and the tracking. And the coming to the scalability issues, we faced some traditional hosting on the local servers like and we came up to the AWS and cannot handle high traffic due to the major events.
Morning everyone, my name is Saviteja. I'm continuing the topic. Our application name is Cloud Native Scalable Web Application, where our aim is to deploy a full stack application named Employee into the cloud. So usually we some of the cloud services in Amazon, such as AWS EC2, is designed as virtual Linux instance. It is used to host the application front end and back end. For load balancing, we use Amazon ALB, which distributes incoming HTTP and HTTPS traffic across multiple instances. We also use auto scaling to adjust the number of EC2 instances. Our main goal is to handle CI/CD pipeline. So we used Git and GitHub for continuous integration and continuous deployment. We used GitHub Actions, which is used to trigger the CI/CD pipeline. As my teammate said, for frontend we used React, for backend we use Node.js, and for database we use MongoDB. For cloud deployment we use Amazon. This is our homepage application. This is our Amazon portal where we use it to deploy our application, where we can use some of the services, as I said, Amazon EC2, auto scaling, etc. This is our MongoDB interface where we use use it to and this is the MongoDB where we use it to handle our databases. We can handle our login form and register forms here to store the data. Coming to the conclusion, our EcoEngage project successfully demonstrated the deployment of a cloud-native web application. We integrated DevOps practices, CI/CD pipeline, automated deployment, reduced manual effort by over 90%. Thank you.
Hello everyone, my name is Krishna and I'm from batch 28 and our project is Cloud Native Scalable Web Application. And so introduction, so cloud computing and DevOps have significantly changed how modern web applications are deployed and developed. So traditional systems often suffer from manual configuration and limited scalability and maintenance challenges. So to solve these issues, organizations now we use cloud native architecture and DevOps practices to build scalable and reliable applications. So our main objective is to develop a full stack web applications, and the main objectives of our project are develop a full stack web application for environmental volunteering, implement a cloud native architecture using AWS, and ensure scalability and load balancing and auto scaling, automate deployment using CI/CD pipeline and MongoDB for database storage. For tech stack, we use in our project we use modern technologies like for front end we use React.js for interactive UI, and backend we use Node.js for server logics. And we also use MongoDB and platform like AWS EC2 and DevOps tools like GitHub. So for system architecture, our system architecture consists of mainly three layers: front end layer, back end layer, and database layers. For front end layer, it handles the user interactions and displays environmental activities. On back end layer, processes application logic and manages user requests. And database layers, it stores user information, event details, and participation records. All these components work together, create a scalable cloud native systems. And for cloud infrastructure, we use AWS EC2 instance, and also for load balancing, uh, load balancer distributes traffic across servers, and auto scaling automatically increases or decreases server load based on demand. And this ensures high availability and scalability. For DevOps implementation, we use CI/CD pipeline. Our project also implements DevOps practices. Developer pushes code to GitHub repository. GitHub action triggers automated build. Dependencies are installed. Project is built and updated application is deployed automatically to the server. And these are the results. This is our front-end user interface of our web application. EcoEngage platform successfully provides volunteer registrations, environmental activity management, and the system demonstrates how cloud native architecture can support community engagement platforms. And These are the results. This is the instance details. This is the Linux instance. It contains instance IDs and public IP address, private IP address. So we have host name types and public DNS names. And these are the MongoDB database details. And coming to the conclusion, in conclusion, the IPEngage project demonstrated the successful development of a cloud-native scalable web application by integrating AWS cloud infrastructure and DevOps automation. The system achieves high availability, scalable performance, and faster deployment cycles. This platform encourages community participation in environmental sustainability initiatives. And thank you.